Well, I guess that I want to start by first saying thank you to Peter for extending the opportunity to talk to you all here. As Tegan mentioned, I'm part of the webinar team on the Whitebark Pine Ecosystem Foundation and also part of the education committee. One of our main role is trying to outreach to the general public, but just people that is not as informed with whitebark that could happen. Many different states in this country about the current situation and importance of that keystone high elevation species. So I reached out to the chart of the state because we were really interested in participating in the MNPS Presents series. And Peter suggested that it was also a good idea for me to, considering that I'm not originally from the States, I come from Chile, to come up with an idea that could compare how the species that I work in either country have similarities and certain differences, but common threats and common challenges. So I came out with this idea. As you heard, I'm a whitebark pine restoration expert, or in the process of becoming an expert. But I started my first studies on high elevation conifers in the Southern Hemisphere. And I would like to know how many of you have been in the Southern Hemisphere, America's principal. All right. Have you heard of any conifers south of Ecuador? Native conifers? No? Well, because there's only a few of them, but neither of them are pine species. So that's a really big contrast that when I was starting my ecology studies here, it was like constructed with a completely different ecosystem. So I was working with conifers, but not with pines. And now my passion is completely devoted to one of the most important, if not the most important pine for me, which is pretty scandalous for my people back in my country, but not for me. So yeah, my presentation today, conifers at the top of the world, linking mountain forests from Montana to the Andes. So the main thing that I would like you to start doing with me is like, try to imagine yourself as if you were up in the high elevation, in the high country, not in the mid of the summer, but sometime later in the fall, maybe in the middle of the winter, and try to imagine for a second how harsh those environmental conditions could be and how long could you make it before you perish, right? It's really hard. So when we're trying to put ourselves in a position where we try to extrapolate how an organism is capable to sustain itself for centuries up there, centuries where you do experience climate change, centuries where you're exposed to multiple threats and still make it, and becoming such a crucial keystone species that everybody surrounded in a downscale from you in one way or another depends from your existence. It puts you in a concept that not just any organism gets there. And that's what really pulls my passion to try to unravel what are the challenges that keeps those pines up there. So we're going to start looking at how those high elevation conifer species are here in the States. And then we're going to move directly to the central Andes of Chile and also Argentina to particularly look at the species with the pretty much bare bowl there. Do you know what the species is? Monkey puzzle tree. Have you heard that name before? I'll tell you specifically where that name comes from. No one in Chile knows by that name, or Argentina, or anybody in the Southern Hemisphere. So let's start with my favorite species, the one that lives closest to my heart right now. It's the whitebark pine. And the first time that I got to see a whitebark pine was particularly when a nutcracker was catching these heats. And I'm going to start throwing those concepts there that might not make sense now until I get to them. But it was really crazy to understand that the way that we get to see a whitebark out there is not because the way that we understand dispersion on species, plant species in particular, but mediated dispersion. I'll get to that in a second as well. But before that, I would like to just give a general outline of what a whitebark pine is. Whitebark, unlike most of the conifer species on the North America, is considered a stone pine. Has anybody ever heard that concept before? So it refers to pine species that have adapted to areas where there are not dispersed by wind in particular, but at the same time that live in super harsh environments. We're talking about not just shallow soils, but super nutrient, how to say, like low nutrient shallow soils where no other species could thrive. Maybe they can survive, but not necessarily thrive. And in North America, we have just a few of those. Most of these species comes from the other side of the pond, where they have something like 5 to 6 of them. But we get to have some of the most unique, right? So that's one of the really cool things about whitebark pine. And the other thing, as you can see on the right side of the panel, is that unlike a lot of other pine species, it has a humongous distribution. With such a humongous distribution, you have to have some sort of adaptation that allows you to thrive not just in one environment, but a multiplicity of different environmental conditions, right? So that means that you need to be a solid rock most of your life. And we're gonna get on what are those solid rock traits for whitebark pine. In particular, the most crucial ones are 3. The first one is that whitebark pine, as I mentioned, is adapted to establish and thrive on really low nutrient, shallow, rocky soils, where most other species maybe could germinate and establish, but not necessarily reach sexual maturity. And that means that it has to have some way to protect itself also from those other environmental stressors, harsh wind and snow in the winter times, and desiccation in the summer. Can you think of a trait that a pine or any other plant species could develop to protect itself from it? Controlling how much they respire, right? So they develop a really thick cuticle and they control the density of stomata in their needles. So their needles are really sturdy, and that allows them to prevent desiccation over the summer and to prevent desiccation and like freezing over the winter as well, right? And as one of your colleagues mentioned, whitebark pine, just by having those traits, grows in ways that the wind can only permit it to develop, pretty much looking like a shrub. Crumples is the actual terminology, but the crumple basically just means shrub-like formation. And the third one is when you're not necessarily putting all your energy to develop cones or to develop like expansive root system or expansive branches, most of that energy goes or it gets allocated to create a really solid core, which translates on a really slow growth rate. So what you see right there is a cross-section of a whitebark pine that was collected in the Araucaria Mountains. Does anybody know where those mountains are? Pretty close here, just something like 5 hours away. All right? That was actually the first mountain range that I got to see whitebark in. Beautiful, I recommend it. So that's related to like what makes whitebark pine so successful in these harsh environments. But it's not just the ecological uniqueness of whitebark pine related to that, but also how it influences everything else surrounding it. Wildlife, other fauna, water retention control and whatnot. But what makes whitebark pine unique is a mutualistic dependent relationship. And that mutualistic dependent relationship is with a birch species or a corvid species. It's called Clark's nutcracker. Well, quick, mutualistic dependent is when it's leaning on one way. Maybe both of species gets influenced and benefited by each other, but one of them cannot live without the other. And that's exactly the case for whitebark pine. The most important trait is that cones on whitebark are indehiscent, which means that they do not open by themselves. They do not open when there is fire, like lodgepole pine, some lodgepole pine. So they need some agent to get the seed out of it. And considering that they do not have wings, they need some process to get allocated throughout the entire landscape. And let's go back again to the image before. Whitebark pine has one of the most outstanding distributions in the Americas. So how did the species get so far, right? And that's because of the Clark's nutcracker. This corvid has developed a special type of beak that allows us to mash through the cone. We're gonna see some of these cones and get to the seeds that are highly nutritious and dense. A single cone could have up to 2,000 calories, which is basically what you need for a full day. So imagine having enough nutritious leverage in a high ecosystem where not much anything else is nutritious rich, That means that like a single cone could not only feed nutcrackers, but also squirrels, bears, black bears, grizzly bears, and anything that you can think of. But that's in terms of like keeping the wildlife around. Now let's think of like how these species actually germinates and disperse around. Clark's nutcracker collects the seeds on their pouch. They could collect up to, I don't know, 15 seeds or whatnot, and start creating caches all over the landscape. Some of them estimate that they could make up to 1,500 cache over a single season, and maybe collect a 50% of them, which leave us with around 750 cache around, which some of them, let's say 5%, get to be on the sweet spot of environmental conditions of enough light, enough water, not getting pilfered by rodents or whatnot. And if they get lucky, they'll germinate. And from those that germinate, let's say that 5% actually get established. And from that 5%, maybe 2% becomes or reach sexual maturity. So every single whitebark pine that you see out there in the landscape is a unique miracle of ecology, not just by chance. It has to like basically achieve all the right conditions so it can possibly be out there. And when you start thinking that it's distributed on such a humongous area and so many species depend on it, you start seeing why we call it a keystone species, right? So what other elements are important in terms of like if its ecology? As Glenda mentioned, whitebark pine develops really strong root system, not necessarily deep, because there is no much where to grab on. But what they do grab, they do hold it pretty hard. And when they hold it pretty hard, then the soil does not erode. And if the soil doesn't erode, then just by like losing needles, we start collecting organic matter. And if organic matter start getting collected and water start getting collected in the same place, then that shallow soil is no longer that shallow. And the conditions are not so harsh for something to get established there, right? So whitebark does have a really strong effect on everything that comes after it. So whitebark is considered a colonizer. It gets to a really harsh place, develop the place, and then other species that are not so hardy, say subalpine fir, Engelmann spruce, do have a chance to germinate and get established. What you see on the right side panel is a picture that I took from nearby fir field, right side of Ketchum in central Idaho. That area is super, super dry. You do not see a single Engelmann spruce or subalpine fir establishing by itself. But as you can see there is a huge dead whitebark, right? And then a complete crown of subalpine fir, maybe some Engelmann spruce and what we call skirts. What is considered to be now a competition or a replacement agent is nothing but the process of facilitation for species that cannot establish themselves. But when we see it, when we see that process with the time frame that we live, so maybe 70, 80 years, it does look like outcompeting whitebark. But those species could not be there if it wouldn't have been for whitebark. And if we start putting it even a larger time frame, when big fires comes around, if a big fire comes around and touches that structure, what could happen? Completely wipes it out of the landscape, right? And what happens right after it gets completely wiped out and there is nothing left? The only single species that can support and thrive on that environment comes back. So when we start looking at it on that long time scale process, we understand that whitebark is not necessarily being outcompeted, but facilitates the process of ecological succession, right? But unfortunately, as any other big story, whitebark also has big challenges. And the big challenges that we know and are familiar with are the native mountain pine beetle infestation or outbreaks and the invasive pathogen or fungi blister rust that was introduced in the early 1900s. But not only that, both of them work together and becomes pretty much the perfect storm for whitebark pine populations, wiping out complete stands from the landscape. And that means that we're losing a lot of genetic richness that will not come back ever. And not so much of that. As I mentioned, there is a concern that with the current conditions of having warmer winters and hotter summers, shade-tolerant species will be able to colonize areas where whitebark would have been completely fine without being replaced. And the other one is just having a higher frequency of high-severity fires. So over the last, I would say, 15 to 16 years, both Canada and United States have increased the attention on the level of risk of whitebark pine and created different levels of protection. In this case, and mostly recently, whitebark pine was induced in the Endangered Species Act. And the important fact about that is that it's the first 3 species to get listed, which is also a big challenge. We don't really know how the policy is going to change and how it's going to impact management and research. But we're in the process of like untangling how these new policies are going to both protect whitebark pine and not necessarily overly limit our management. And as long as we keep creating more awareness on the necessity for conserving whitebark pine, newer strategies for restoring it or for protecting it on different regions of it comes around. The most important is the current National Whitebark Pine Restoration Plan that pulls a lot of the information that was initially championed by Bob Keane and his collaborators in the 2012 Range-Wide Restoration Strategy, that in other words, collects different types of techniques that we could use to preserve certain stands or to restore areas that would have been populated by whitebark pine, having these one not being wiped out of the landscape. So that's why whitebark is so close in my heart. It is the most challenging problem in ecology right now. But now let's move all the way south to the central Andes. I know we're skipping a whole bunch of different areas in between, but neither of those regions have high elevation conifers that are so unique. And you'll see why. So the next one that I want to introduce was probably the first love as I had as an ecologist, and it's the monkey puzzle tree. I know it with different names, but when Araucaria, not monkey puzzle tree. And it's a really important species because, as you can tell, it's really oddly looking, right? What's the first thing that comes to your mind when you see that? In my case, I see an umbrella. So imagine going to the Andes. You get to the Piedmont or the, how do you say that? Foothills of a volcano, and you just see umbrellas everywhere and nothing else, just black rock and umbrellas. It's the most odd landscape that you can have, even present, have an experience of seeing it. But that when you see that structure, most of the time is a tree that has already surpassed 150 years. The structure of an Araucaria before that is more related to what you see over here. Doesn't it look odd? How would you describe it to somebody that has never seen? It's odd, right?
Dr. Seuss.
Dr. Seuss. Yeah, actually, that's a good one. That's a good one. And the cool thing that making it more different than whitebark pine is that it has a rather segmented or fragmented distribution. As you can see, most of the distribution of these species is collected around the Andes, both Argentina and Chile, but then there is a little pinch right on top of there. And that tells us a lot about the ecological history of this species. This species is not just old, but it tells us before the glaciation or the maximum glacial level, it used to be completely dominated the entire central valley of Chile and also extended to the Pampas in Argentina. So by seeing how that is distributed today and what changes must have happened even after the glacial schemes around. And the cool thing is that Araucaria is one of the most unique genera for conifers in the entire world. In particular, this species can be traced back to 200 million years, which means that they were with the dinosaurs, right? So it's pretty cool to think that something like this was way before the first flower and not so far from the last arboreous ferns, right? In South America, we have 2 species. One that is closely to the, I would say, southeastern side of Brazil, Araucaria angustifolia, and then Araucaria araucana, which is the oldest one of the different type of Araucaria species. And it can be traced all the way back to Gondwana. So the continents as we see them today were not even shaped that way, right? So if we start thinking 200 million years, these species must have overcome tremendous changes in climate, tremendous cataclysms, whatever that word is pronounced, volcanic eruptions and whatnot, and it's still around. So you would expect to see when you get close to one to be pretty sturdy, right? Let's take a look at that. Oh, wait, I forgot to mention something. When I defended my thesis, I was studying monkey basil tree, but something really particular. In the 70s, during the dictatorship in Chile, they tried to introduce multiple pine species to see which one of them was the most productive on different types of soils. And they introduced lodgepole pine. And lodgepole pine broke free. And now it's considered the most invasive, well, the pine species with the most invasive potential in the world. Because of one element on its own, if we go back to the Latin name of it, Pinus contorta, the contortus aspect of it pretty much speaks for how it can live even under the worst conditions ever. And I was studying how the regeneration of Araucaria was being affected by an extremely dense patch of lodgepole pine regeneration. The cool thing about that is that after 20 years of really thick invasion, I did not find an effect. The seedlings were still there, just waiting for their chance to survive. That speaks a lot how resilient it is to like extremely harsh conditions, even extremely harsh light conditions, right? And the cool part is that when I defended my thesis, I put a picture of like walking with dinosaurs, where it was a T-Rex, not particularly this one, but it was a T-Rex looking back to a whole bunch of stands of Araucaria. It was the most epic time of my life until then. So let's go back to that. What makes these species such a good adapted or so properly adapted to strong changes through 200 years of existence? When we get close to it, we start to understand how is it so like, how to say, like hardy. First of all, you don't get to see needles. You don't get to see leaves. You see an adapted version of a needle that is an extended like version of it, extremely hard and extremely dangerous to grab because it's pretty much like grabbing a cacti. And that is really helpful because it prevents, as I mentioned, desiccation over the winter, desiccation over the summer, but most importantly, if you're trying to eat something that is that harsh and that pointy, would you eat it? No, right? So that made it really, really successful with guanaco and other ungulate species, right? But the second most important trait is the bark. The bark, as you can see, creates these huge clusters or like almost like pieces, right? And that's exactly where the name puzzle in the monkey puzzle compound word comes from. This is not to scale, but actually, if I put my head here, it would be pretty much to scale. You'll see that at the end of the presentation. So in that sense, when an Araucaria tree reaches maturity over 150 years old and completely prunes all the branches, it becomes almost fully resistant to fire, unless the fire is too predominant, right? But there are other elements that we need to consider as well with these species that are rather similar to whitebark pine, but not the same. As I mentioned, whitebark cones are super nutritiously rich. In this case, I don't have cones with me of whitebark of Araucaria. That would be a violation of like regulations. But every single one of those piñones or those seeds, pods, it's about the size of a AA battery. And it weighs about 2 times a AA battery. So think about how much nutritious content you can find in it. And a single cone, which could be 1 out of say 20 or 30 per tree, it's about the size of, well, does anybody like Dixon melons? It's about the size of a Dixon melon, but times 30 per tree. times as many trees you have in your state. So that's a huge nutritious influence on the ecosystem, right? And that was taken advantage by the human population that was in the time at the place, which is the Mapuche Pehuenche. And it's really interesting because Mapuche means people of the land, Mapuche, and Pehuenche means Pehuenche. Pehuen is the name of the species. Che means people. So Pehuenche means people of the Pehuen. That's how culturally important the seeds of the Araucaria is for them. They live with the seeds and created flowered and basically subsisted mostly with that. We don't have big ungulates other than a single endangered deer species in Chile. We don't have nothing like bison or anything else or bigger predators, maybe pumas, but most of like the food that native communities depend on were based on vegetation. But similarly as with whitebark, the threats are big. We don't have mountain pine beetle, but we do have a foliar fungi, which was identified to be something like 102 different types of fungi attacking a single individual that cannot be treated, and you can only see it coming. And that means that your stands are gonna die. The other one is the increase in wildfires and severity of them, and most unfortunately, the desire for commercializing these species in the early 1900s. It's not longer commercial. There is actually, it was converted as the natural monument of both Argentina and Chile, so it's protected. But fragmentation and land use change completely wiped out all the populations that were remnant on that central valley area that I showed. So yeah, two really important conifers. Really, really important, a lot of similarities and a lot of like counterpoints. And I wanted to first like point out the similarities on why these species like became so successful in the areas that they're thriving. Whitebark pine and Araucaria, they're both living in that area not because they're just hardy, is because there are no other species that can outcompete them. If we start thinking at the adaptations that make them successful up there, they do not grow fast, right? So under any other stressor with a higher growth rate species, it could completely get like outcompeted in a matter of like years, right? So what makes them hardy is essentially having those traits and living in areas where no other species can and oh yeah, I already mentioned this, like the strategies for survival. But now let's focus on what makes them more distinctively unique. And I'm gonna talk about more uniquely for each species. For Araucaria araucana, unlike whitebark pine, as you mentioned, this species does have a bark development or a bark trait that allows to resist most types of fire. So when you do see a fire like killing killing an Araucaria, it's not because necessarily crossed the bark, but because it found a way or some sort of like ladder of fuel to reach the ground. The strategy for these species is to completely avoid lower or shallower wildfires. And this is like the picture that I was talking about. So those blocks were actually to scale. They're humongous. But you can only see them when they reach something like 70 to 80 years old. So when they're already fully developed and they're using all their energy to produce cones. Everything before that, they're still trying to make it, trying to self-prune their branches and whatnot. And as I mentioned, some of the distinctions on the type of nutritious contents of both species is that Araucaria is structurally, culturally important for the Mapuche communities, when whitebark pine nutritious contents of the cones are more important to keep the wildlife around subsisting. And the bird that you see there could be a really close analogous to what we consider Clark's nutcracker. But the big difference is that these parakeet, cachañas, they eat about 2/3 of the cone. I mean, 2/3 of the, what would you call that? Seed, thank you. And then they just get rid of it. And there is a really cool study that they were trying to look at those last third pieces and see if it was still possible to germinate. They tried hundreds of different of them, and they found an over 80% successful germination rate. So it means that they're not necessarily killing or dispersing the seed on purpose. It's mostly like by chance, pretty much like Clark's nutcracker. We cannot tell that the species is like basically planting whitebark, but yeah, it's something similar, but it's not a mutually dependent relationship. And for whitebark pine, as I was mentioning before, unfortunately, this is not a species that has developed any type of resistance to wildfire. Actually, within the species of conifers in the western states, it has one of the lightest or thinnest barks of them all. And there are a few studies that says that any type of fire that touches the bole could produce mortality within the first 5 years. So when we start thinking about the type of management we do that includes prescribed burning, we might be killing certain trees, but we still don't have enough evidence to prove it, but suggested evidence that says we should not do it. And yeah, as I was mentioning, the type of biotic relationship it has with the Clark nutcrackers is mutualistic, has a mutualistic dependency, because without the Clark nutcrackers, we wouldn't see 98% of the trees out there. So, despite the difference, both species are the sentinels of the high elevation mountains on either side of the hemisphere. And without them, we wouldn't have the ecosystems that we have them today. So it's really important that when we start like gauging what is our role in the conservation of these species, we start trying to connect all these little intricacy traits and threats and challenges and whatnot. So I'm going to start like wrapping up this presentation with this motto, which is the future of high elevation ecosystem is a shared responsibility. And this is my favorite part, because for conservation, we can't just rely on research or managers. There is a big role for your regular Joe walking out in the street. Every single one of us can do something about it. And that's when we need to start reaching out where we can do something for some of these species. Maybe we do not have the reach to do something for monkey puzzle tree, but we live in the most important place out of the distribution of whitebark pine. And we also have the most important organization that cares for the conservation and restoration of these species, the Whitebark Pine Ecosystem Foundation, which you're lucky enough to have the share of it. Glenda Scott sitting over there. So what we can do about this? In this case, it's reaching out to these organizations and seeing what are their options for citizen science, what are their options for volunteering. And we do have probably one of the most active volunteering communities here in Missoula. And we have whitebark pine less than, say, 20 miles from distance right now. Most of them perishing right now, unfortunately. But it's a big opportunity to get involved with either of these organizations and make a difference. So I'm going to finish by reading a reflection I wrote and also making an invitation. So ultimately, these summit conifers remind us that the mountains are more than just landscapes. They're home to unique species, shared stories, and a reminder of our connection to nature. By protecting these mountains, we are ensuring that future generations can also marvel at the resilience of the whitebark pine in the Rockies and the majesty of the Araucaria in the Andes. And my invitation is to participate in the webinar series that we have at the foundation. We try to do our best to share the ideas and projects that researchers and managers and citizen sciences are putting out in the field throughout the distribution of whitebark pine. And if you want to be part of that, you can reach out to me or Glenda. Thank you so much for joining me in this journey, and have a good one.